Welcome to Meteor Interviews, a series of interviews with Meteor developers. My name is Paul Dowman. This podcast is produced by OKGrow. We build web and mobile apps for clients using Meteor. You can find us at okgrow.com. I have a quick announcement before we get started. I'm going to be teaching 2 full-day Meteor workshops at HTML5 DevConf next month. That's in San Francisco on October the 21st and 22nd, 2015. One is a beginner class and one is intermediate, where we'll get into deeper topics. The enrollment is limited and you can find more info on the HTML5 DevConf site or at okgrow.com/meteor/learn. If you missed that, we also do a 2-day workshop pretty regularly, and you can find more info about that at okgrow.com/meteor/learn. Today I'm speaking with Dean Radcliffe, who's a senior developer at OKGrow. Welcome, Dean.
Thanks for having me, Paul.
Thanks for coming on. So my goal today is to dive deep into asynchronous programming in JavaScript. So first, tell us about your background as a developer and how long you've been working with JavaScript.
All right. Well, most recent programming enterprises have been, Ruby and JavaScript and .NET. So those are like maybe the past 7 years. But I really got started with JavaScript in 1996 was when I wrote my first code to enhance some HTML pages that was running in Netscape Navigator.
Same here. I remember the release of Netscape with JavaScript in it. Oh boy, we're old. Wow.
Yep. You're a little older.
and yeah, so JavaScript has been something that a web developer has had to do a little bit of for years, forever. But now it's obviously, especially for Meteor developers, now it's a big thing. So
yeah.
So, and I think like the biggest thing that distinguishes JavaScript from most other programming environments is that you use asynchronous programming constructs a lot. So for someone who their first programming environment was JavaScript, they're probably familiar with using callbacks and event handlers, but they might not fully understand all the other constructs like fibers and promises and ES6 generators. So we'll get into that stuff.
Yeah.
And if Meteor was your introduction to JavaScript, you might also be confused about why you hear so much talk about these things, like promises and whatnot, but you find that you're not actually using them as much as other JavaScript developers seem to be. So let's talk about all of that stuff. But first, let's take a step back and let's just talk about concurrency in general. What is it, and how do we do it in JavaScript?
Yeah, well, I wanted to say something to what you said is that everyone has done a little bit of JavaScript development, and if for a while you only wanted to do a little bit of JavaScript development. You wanted to do as much as possible in some other framework, and now you can just tell that everyone likes working in JavaScript so much that the new framework is coming out every couple of weeks. And so what you touched on about being able to do asynchronous programming was one of those things that I didn't know I was missing until I really got into JavaScript. So let me go back to rewind a couple of jobs to where I was working Ruby on Rails job. I say that because maybe that might be like the more familiar to people than like some .NET server code or PHP server code, but it's really all the same. Just think about server-side code, and you write, get me some data from the database, and then you pretty much know that on the line of code after you say fetch the data, however long it took to fetch the data, the thread of execution that you're on, but from your perspective, the code that you've written has waited for the database to return the data, and then you had to expect that so that you could loop over it and concatenate your HTML to emit on the server side. So working in that kind of world, as I was for many years, there was no need for async. And of course, you wanted the server to be able to optimize itself so that while it was, getting my result set from the database, or rather for like user number one, you want the server to be smart enough to be able to multiplex several users, but you were never in charge of yielding. You just wrote code that was kind of greedy. It just says, use whatever resources necessary to get my database results use however much time it takes so that I can write, top to bottom synchronous code. So there's nothing wrong with that. I don't mean to make that sound like terrible, but what asynchronous coding constructs let you do is really chunk up that work. And if you do a little bit of chunking up the work yourself into the different stages that you might want, the server to be able to do other things, then what you find, as was discovered when Node.js hit the scene, Node.js libraries were written to yield, essentially, which is saying, I'm waiting for some stuff from the database. I'm just going to poke my head out of the rabbit hole and look around and say, anyone else needing to get some work done, now might be a good time for you to do it because I'm just waiting. And so we saw amazing performance numbers from Node.js by virtue of it being able to run asynchronous code, and by it forcing you to write asynchronous code, that allowed the Node.js runtime to interleave the bits and pieces in the most efficient way.
Right, and save memory by not having multiple threads or even sometimes multiple processes like the early Rails versions forced you to use. Yeah, so if you have a lot of idle connections too, then you can have you could have thousands of idle connections without having thousands of threads duplicating the heap and all kinds of other memory that's being basically wasted.
Right, precisely. And with more and more service-oriented architectures, starting going back to the Java world, there were remote objects, and Microsoft world is also crazy about distributed COM and talk to your objects as if they were locally. You just instantiate them and call some methods on them and get your results, but there's an entire network hop in the middle, and then it's like, oh, wait, so I don't know whether this loop that I'm doing is making round trips to another machine. I mean, you'd like not to care. You'd like to think it's fast enough. But in practice, trying to tuck that fact away from the programmer ended up kind of doing a disservice. It can be much nicer to allow the programmer to control, essentially to make an async call, because when the programmer chunks up their program that way, they are being mindful of when resources when they might be idle, essentially, waiting for an answer. And so async programming in general, and I'll talk about maybe at least 5 ways of doing async programming, is really all about allowing you to be idle, which who doesn't want to be idle once in a while?
Yeah. And the JavaScript runtime, you don't even have the option of using threads because the JavaScript runtime is single-threaded. So,
right.
So,
but things come full circle, and things that were once at the bottom of the stack get wrapped in other abstractions. So while that was very true, and it is very true in general about the JavaScript runtime that it's single-threaded, there's the web worker standard of HTML5,
right,
which lets you effectively spin off another process. And so it seems like every rule has some kind of exception, but that's definitely the way to think about JavaScript as a single-threaded environment.
Right. Yeah, and of course you could have multiple node processes as well, which you would do for performance. But let's not get into that yet. Let's talk about why asynchronous programming is hard, or what are the pitfalls and problems with it that we end up with so many different constructs and patterns to be able to work with it.
Yeah, well, I've been introduced to, when talking about complexity, there is the incidental complexity of the problem itself, and then there is the accidental complexity, when, the first solution to the problem that is presented is, not optimal. So what I'm referring to specifically is that in order for Node.js to get off the ground and for people to really see how JavaScript can shine on the server, there needed to be some asynchronous programming model. I don't believe promises had been invented yet. I don't believe fibers had been invented yet. But even in the earliest version of JavaScript, you had the ability to store a function in a variable and pass that function in as an argument. You also had the ability from JavaScript earliest that I can remember is the ability to do a set timeout and basically create a new call stack of execution at some point in the future. So neither of those constructs are super impossible to understand, the storing a pointer to a function in a variable or causing something to occur at some point in the future. But of course, I say that having done it for a long time. I'm sure like when you're learning it for the first time, some of those things might be a little bit strange. But I think that's about it for the incidental complexity. And then we started piling on accidental complexity. So you're probably familiar with when you pass a callback to a node asynchronous function, you're familiar with the standard method signature for a callback, I'm assuming?
So a callback and an error function, or success and an error callback.
Okay, so some libraries take a success and an error callback, like a jQuery AJAX request. But in Node, it was more typical to have what they called these airbacks, which are functions whose first parameter is an error and the second one is a result, right? So you're familiar with that airback type of thing?
Yes.
Okay. It's different in client and server, but in Node server, that's by and large when you pass a function to be executed at the end of a batch of work, so a callback function, the function's supposed to take an error parameter and a result parameter. And rather than using exception handling, which was slow to catch on in JavaScript, actually, the idea was that if anything went wrong during that processing, the first argument to your function would be the ERR. That's typically what it's called. And you would do a null check for that. So if it's a non-null or truthy object, then some sort of error occurred. So when callbacks became the way to do async, it led to a lot of incidental complexity. The first part being you don't have what you said was a success callback and an error callback. That's how jQuery does it for AJAX. That's nice. It separates the happy path function and the sad path function. And most of the time, programmers can be optimistic. And we first start writing the happy path code. And when you separate the functions into success and error functions, then the programmer just writes the happy path code. When you combine them into a single function, and this is a generalization, but I think it might be true, you're trying to write the happy path code, but of course they make you deal with that first argument. And so people end up writing extremely shoddy, afterthought error handling code, myself included, right? Because I don't want to ignore that ERR parameter, but it basically ends up being if ERR console.log ERR and then a return.
Yeah, there's a lot of times you actually don't want to handle every possible error in a particular function, and this is why languages with exception handlers, although people kind of have said that it's like a go-to statement, in a way it's good because it allows you to write simple, straightforward code that doesn't have to handle errors, and then know that error can be handled somewhere up in the chain. Higher up in the call stack if it's a normal asynchronous programming language, right? Right.
That's exactly right. You can write your happy path code, wrap it in a try catch, and then even have different catch conditions for the kinds of errors that code may throw.
Right. And you might have an outer function that calls everything, that just handles all your exceptions and says, if anything goes wrong in here, then we'll just abort the whole thing. And each function you write inside that's going to be called by that doesn't have to worry about handling exceptions. Okay, so
Right.
Okay, so go on about the node style callbacks.
Yeah, so that's what we got started with, and it was great. It brought Node to everyone's attention. I was watching a talk, and I'll try and give you the URL of the talk to put in the show notes. But somebody was discussing how this airback. There's a lot of implicit assumptions about Node airbacks, and I won't go through all of them. But one of them is that if you are writing a function that takes one of these callback parameters, you should never call that callback function. And I'm saying you're the author of this library, and you say, I'll do some work for you. Give me a callback function to call when the work is done. Libraries differ in whether they call that function synchronously on the same turn of the event loop or asynchronously. So simply because you pass a function into another function doesn't mean you're doing async programming. It looks that way. Most of the time it is that way, but it's really up to the library author whether they call your code synchronously or asynchronously. You might do you want to know why that might matter?
Yeah.
Because I had to kind of rack my brain a little bit. So
Yeah.
Why does it matter?
I don't know if I understand that. So maybe your explanation will help.
Okay. Typically, if I were to say read the contents of a file, I would pass in a callback that would receive the contents of the file in a parameter. Now, it could be that this library has to do some work from the disk, and that it's actually going to go idle and yield, and have to access the file from the disk, and then call your callback function asynchronously or later.
Right.
But it could be, suppose this library was optimized where it says, oh, that file, I've got the contents of that file in memory right now. Let me just call your callback function right now.
Okay.
Well, there are different implications for exception handling when it does that. And there's different implications to the person who, what if there's an error what if that file is very large that you're returning? Or what if trying to get the file from the cache, something goes wrong? Well, a synchronous exception is different than an asynchronous exception. And there's little it's a leaky abstraction. If the library can choose whether to call your function synchronously or asynchronously, you can end up with some very unusual error conditions.
Is this because you might not be still in the same call stack in the asynchronous case?
In the asynchronous case, if you're in a different call stack, then it's expected that the ERR object will be populated. But if you're in the same call stack and that function is called synchronously, things could take longer than you think they ought to take. Right? So suppose you're going to read the contents of the file and then take away the user's spinner. You put up a spinner, read the contents of the file, and take away the spinner. If your code is written that way, if that middle step of reading the contents of the file can sometimes be synchronous and sometimes be asynchronous, then that spinner may or may not be removed right away. Right? So the user experience could suffer if all of a sudden some synchronous work is being done that we thought it would be small, so it's fine, we just said go ahead and do it. But when you make things async all the time, then that the cost in this particular turn of the event loop to do something is going to be very small, and then however long it takes to complete, it will come back later and get that.
Right. So that's a good thing to have it asynchronous all the time, so that you can know that you don't call a function and that it's going to go and block for a long period of time, I guess.
Right. It can be a good thing. I'm not saying never write a library that occasionally does this, but what you get with promises is a guarantee. And it turns out that with the Node airback implementation, different authors did it differently. Another implicit rule about node airbacks is that you're never supposed to get an ERR and a result. Also your callback function, you're allowed to pass a return from it. You're allowed to return something out of it, but a properly written library is not supposed to care about that return value. I'll really have to just forward you on to the presentation, but it blew my mind. The promises standard evolved after the callback standard, mainly, well, which isn't a standard. Callbacks aren't a standard. Promises are a standard, and they formalize things like, are you allowed to call a part of the promise chain in the current event loop? And the answer is no. It will always be in a future turn of the event loop. And so it makes promise handling code very uniform in the same way that jQuery, when you're querying DOM nodes, you can, reduce your set of DOM nodes, increase your set of DOM nodes. As long as you're staying in jQuery land, you have this really consistent expectation of behavior. And you know how it feels when you leave jQuery land and end up with a regular old DOM element that doesn't have all the conveniences on it. Well, that's kind of what it's like. Yep. That promises give you a wrapper that you can count on the behavior of that wrapper. And so I think that promises are like for async what jQuery is for DOM node selection.
I've never heard that analogy, but that's a really good one. So let's kind of let me just do a summary for someone that may not know what promises are yet. So I think we'll get into it. So you've said that we've got at the most basic level in JavaScript, we've got the concept of a callback, which is just calling back another function because you have a reference to it.
Yep.
They're not exactly standard. So like you said, in Node, you have this error first style, and in jQuery, you might have or in any other library, you might have what I mentioned earlier, which was like you might have two callbacks, one for an error, one for success.
Right.
And so you're saying that promises are like an abstraction on top of callbacks that give you some guarantees. So maybe explain a bit about that for someone that doesn't totally understand it.
Yeah. Also, I want to kind of demystify it. That promises can be written in JavaScript that you can write. You could write. It can be an exercise, right? If you want to get into advanced JavaScript to write these kinds of a promise-like object. In fact, there's many implementations of them. So although they are a part of the JavaScript language specification as of ES6.
As of now.
As of
ES6,
As of ES6, they're part of the specification of the language, which is great, but it's really just a convention and a helper object. So I'll compare it where you do in jQuery. jQuery did introduce promises pretty early. So in typical, if you're doing a remote AJAX get, it'd be $.get the URL. And for the longest time, you were able to pass in a success callback and an error callback. Now, when they went to promises, you just simply say $.get and you pass it the URL and you omit those parameters. Well, how do you then deal with what happens on the happy path and the sad path later? Well, what you do is you call on the object that was returned, right? So it returns something immediately. It didn't return the contents of that remote URL, but it returned something immediately. It returned an object on which you can call .then and pass the happy path result handler function, and then you can call .catch and pass the sad path function. And so what that does is actually a trick in programming called an inversion of control. So what that means is that in the first case where I passed a success and an error callback, the library that did the HTTP stuff has a pointer to my function, and it is that library's responsibility for calling my function. In the second case, I said, give me a promise for the result, and then I chained on the .then and the .next, or .catch actually. And by doing that inversion of control, it makes it very simple for the author of a library to say, look, I'm not going to, care about what kinds of exceptions may be thrown when I call somebody's callback function. In fact, I'm not going to have a reference to these callback functions at all. I'm just going to resolve or reject. I'll just announce. It's kind of like PubSub. I'll announce whether I was successful or not, and if I was successful, I'll give the remote results. And that's all it's doing. It's kind of like raising an event, essentially, that something on the outside says, oh, you raised here's your content event. Well, that's what got passed into my happy path callback function. Does that make sense?
It does. Thanks.
Cool.
Okay. So why do we want to use promises then instead of just using like a convention? So like if everybody would just stick with one of these conventions for what the signature of the callbacks look like, what makes promises better than that?
Well, I guess for the library author, what I just mentioned, that it is not your responsibility to call a callback function. That actually is kind of a relief, because I've thought about, what if in the process of calling this person's function, it does something nasty? Do I have to handle with that? It's very clean to just basically announce the result or announce an error and not care. So from a library author perspective, that's definitely an advantage. The guarantees of behavior are an advantage. And also, when I give a talk about promises, I call them promises the unsung heroes of async. And I have 2 slides, one that shows a 2-step asynchronous call done with callbacks and one done with promises. The one done with callbacks is approximately 14 lines long and about 6 levels of indentation. So if you squint, it definitely looks like a arrow pointing to the right, also known as the callback pyramid of doom. And then the promises version is literally 4 lines and only 1 level of indentation. It looks like a square brace pointing to the right. It goes inwards, it stays inwards for a while, and it doesn't get any more nested, and then it comes back. So if you extrapolate that to chains of more than 2, you really can have some savings in conciseness. So I see lines of code, but what I really mean is conciseness, where every identifier, every function name, every token is very pertinent and self-explanatory. Not a single if condition in the promises, not a single try catch. Just chaining happy path handlers and sad path or error handlers. Cool.
So is it fair to say then that when you use promises for all your asynchronous code instead of having callbacks being passed around, that you can write functions that don't have to worry about error handling, that can be chained together, that don't have to worry about error handling, so that one of the later functions in the chain can handle it?
Yeah.
Is that fair to say? That'd be an advantage?
Yeah.
Okay.
It is. And okay. I could receive a promise into my method and then add new behavior, including new error handling behavior to it, and then return it. So you can kind of build on these things.
Cool. So I find that in Meteor, we don't tend to use this stuff very much, like even callbacks, right? So in Meteor, we've got, I think, other ways of doing things. We have fibers on the server. We have reactivity on the client. So how does this affect Meteor developers?
Yeah, that's a great question. And my early days with Meteor, I had some extenuating circumstances where I couldn't use Mongo, for example, and had to do some other kinds of non-usual Meteor things. So that's what initially led me to this. But where I see the opportunity to use these now mostly are third-party library calling, and then Meteor method calling on the client. So Meteor method calls made from the client take in callback parameter. And I don't know if it's typical. I wouldn't say that it's necessarily typical to have to chain a bunch of those together, but I've certainly seen a few instances where you needed to make a series of method calls. And the idea isn't that, sure, you could obviously write one method that encompasses the functionality of the two methods. But if you needed to maybe conditionally call the second method, those are situations where you'd be getting into, callbacks and nested callbacks. So Meteor did really well by keeping callbacks and thus the need for promises as well out of the critical path of a lot of developers. And let me just explain for an example. So where you wouldn't necessarily need, how you might do things the reactive way instead of a promise-based way. And let's see if we're like on the same page about that. So if I have to make a remote HTTP request, I can pass it a callback. And in that callback, and let's say that I want to display like the result of that on a page. So I can have a helper that looks at a reactive variable. So I'll define a reactive variable whose sole purpose is to hold the result of the HTTP call when it comes back. Well, I know what I can do with that reactive variable. I can reference it through a helper and embed it into my template. And then I do the HTTP call. And in the callback to the HTTP call, if there wasn't an error condition, then I can set the value of that reactive var. And that is entirely a valid and very meteoric way of doing things. And I would say the only change I would make to that is use a library that turns HTTP calls into promises for HTTP calls. And then instead of passing it a callback, I would chain a .then handler and still set the reactive var. So you'd notice very little difference between those scenarios.
Right. And in the first case, what's actually happening is your reactive var might be set to something undefined or null or whatever the stub of the method call. Because the Meteor method call, that same function will be run on the client. This is the latency compensation. It'll be run on the client. Yeah. It might assign something to that reactive variable, and then your UI might like temporarily show something. But then when the result finally does come back from the server, and that reactive var is changed, then your helpers are all going to be rerun again, right?
Yeah, exactly. No, I'm glad you mentioned the client-side method stubs, because those are kind of needed, right? Before the result comes back, there's a pending state. And so in Meteor, the method calls pending state is taken care of by the client-side stub. So it's a completely isomorphic or one-to-one correspondence between promises, which there's this OKGrow promise package that we have that we'll talk about in a little bit. It lets you use a promise for the value of a helper, and so in what it has is a loading text, a pending, a value to use during the pending stage, because both the Meteor way with the client and server calls and the promise way, they have a stage where the promise is pending or where the method call is pending, and then they have the happy path and the sad path. I think it's a kind of a universal architectural pattern, actually.
Right. And sometimes you might just be optimistic with what your pending value looks like, right? If you're maybe posting a comment, you and updating your UI to show your own comment posted, maybe the pending state will just be comment is posted, here it is, and then when the result comes back, it looks the same. But sometimes if you're waiting for something that comes back from the server, then you might have a different pending state.
Yes. And so there was an example where I was in a web page called packagekitchen.meteor.com. A lot of package or if you're authoring a Meteor package, a lot of authors will include a demo site. And so I had a form field on which someone could specify their demo site. For example, deanandpaul.meteor.com. And I wanted this, as soon as someone typed into this form field, I wanted it to do an HTTP request of that, which I could tell whether it had, a success code or not. Actually, it wasn't quite that straightforward, but for this purpose, it was like just about that easy. And I just wanted to say, like, happy path, show that the domain name is available, and sad path, show that it's not available. And I didn't really want a reactive var or a reactive dict. I just really wanted to say, like, as soon as you know whether it's available, toggle this piece of the UI, kind of, imperative style. So it could have been done with a reactive var, but I was working on, the promises library, and I said, it can also be done with promises. And sometimes it's just more straightforward to say, after this, then that.
Right. And sometimes it's confusing when your code gets called multiple times with different values, sometimes with null or undefined. So that's interesting.
Mm-hmm.
And on the server, let's talk about why we don't tend to see a lot of asynchronous programming constructs on the server side in Meteor.
Right. So remember, like, asynchronous is all about yielding at a certain point in time so that other work can get done, and then control coming back to you. And so on the server, there's the wonderful Meteor.async, Meteor.wrap async function. And if you've ever needed to call what is an example, Paul, of a thing you would need to call on the server side that would, be asynchronous?
A Mongo, something that you would need in Meteor to be asynchronous. So, I mean, a Mongo query would be something asynchronous, but you don't write it as if it is.
Right.
But maybe something that you would need to write as if it's asynchronous. Well, I was going to say maybe making a request to an API call somewhere else, but Meteor has
that's kind of
the HTTP package for that, which is also.
Well, yeah. So actually,
if you're using an NPM, okay.
Or using an NPM module, certainly like a GitHub query, or even like a remote DDP call to another server. But let's use the inborn HTTP package, because people ought to be familiar with that. So on the server, http.call allows you to omit the callback for the result and the error. So what does it do? So there's the Meteor.wrap async function, which I introduced because it will take any library that takes a few parameters followed by a callback that's expected to be the node error back kind of callback. And Meteor.wrap async will turn it into a synchronous looking version of that. So a synchronous looking version is http.call on the server, where you can omit the callback. So what happens is that when you make that call, what Meteor.wrap, you can think of the server-side version of http.call as doing a Meteor.wrap async on the client callback-taking version of http.call. And so when you call anything that's been Meteor wrap asynced or written that way, to use fibers, at the point of doing the work of setting up the HTTP request, at the point where it's going to idle, it uses an NPM package to basically suspend your code of execution and allow other code to run in the background. And then when the result becomes available, it revives your thread of execution. Now, you did say that Node is single-threaded, and it is, but fibers are a magical kind of thing that allows there to be more than one call stack going at a time. So if there are two server-side calls, each one doing HTTP to different places, and I reach one of them, it starts the http.call, then because it has to wait on that result, that one gets suspended, and then the other one can begin running, and it can run up to that point where it too will be suspended. And then, whichever order they come back in, they get unsuspended in. And so it basically wraps this pattern up into an invisible, wonderful thing that all you have to do is do http.call and assume that it will either throw an exception, synchronously looking, or it will, give you the result in a variable immediately.
Cool. So that's a Node extension that I think has to be compiled in. So they couldn't have done that on the client. I assume they probably would have tried to do that on the client if it would have been possible, but has to be compiled.
Right.
In. So that lets you do something like just assign a return value from an http.get or from a collection.find or whatever. And even if there's a network request there, which there would be, that takes a little bit of time, you know that your node process isn't just blocking and doing nothing. It's going on.
Yeah. Right. That's a really good point. Is that in comparison to like the DCOM world of Microsoft, like where initially when we were doing this remote stuff, we wanted it to look synchronous, but it wasn't, and so we paid the performance cost. So then we went through this phase where we rewrote everything to be async, and you had to write async for everything. And then this fibers layer came on top and enabled us to push some of that complexity back down, where we are doing a remote call and we have all the convenience of assigning it directly to a variable. It's pretty neat what they've done there, actually.
Yeah, and you can wrap it with a try catch, so you can have multiple like queries going against your database, and if one of them raises an exception somehow, then the right try catch handler will be invoked with a call stack that shows something meaningful.
Yep.
That's pretty cool. And on the client,
but there's.
I was going to say on the client, when you do var x equals collection.find something, that is actually synchronous, right? But we just assume that it'll be fast enough that it might actually block your browser's thread of execution for a few milliseconds. But we assume that your client-side collections are small enough, it's not making network requests, it's predictable and probably fast enough that it doesn't matter.
Right. Yeah. So the fibers, were a very good choice. But as is often the case with first choices, another choice comes along and looks shinier and more appealing. And so I want to mention the promise equivalent of that Meteor.wrap async example. And it just came in really recently when the Meteor community got Ben Newman. And Ben Newman did a lot of stuff with JavaScript and promises, and he's actually in one of the JavaScript language committee working groups. Very astronaut-y stuff. But what he gave us is the line on the server, promise.await. And the same way that Meteor.wrap async lets you assign the result of an http.call directly to a variable, if you have a promise for a value and you wrap it in promise.await, it does basically effectively the same thing as Meteor wrap async. It will suspend your code until that promise has resolved, and then it will give you that value. So you can take things. Meteor wrap async lets you take things from callback land into synchronous style coding land, and then if you have things in promise land, then promise.await will use the same fiber-based magic under the covers to allow you to have the exact same conveniences.
So would you only use that for interacting with other code from, say, an NPM module or something? Like, is that something you're going to ever want to use with core Meteor libraries, since they mostly use fibers and let you ignore the whole asynchronous thing altogether?
Right. as long as they're using fibers, you won't need to use promise.await. And I don't want to speculate on how much of Meteor is going to change to be promises. But one of the things with fibers isn't exactly in line with Meteor's vision is that Meteor is all about isomorphic code that works the same way on the client and the server. So there's two possibilities here. One, they're very forward-thinking and thinking that eventually with JavaScript 7, some of the new language primitives will allow fiber-like stuff to be done on the client. Or they just said, hey, we're going to go with fibers now. No, they don't work on the client, but I guess we'll just say, we're pretty isomorphic, right? So there's a chance that more things will be done with promises just because once people get used to that, they'll be used to it in both places. Just imagining, though.
Right, and we seem to be working more and more with other things from the JavaScript ecosystem that come in from NPM or whatever. So perhaps it's also just trying to fit in with the rest of the world a little bit more, maybe. Yeah,
it's certainly handy. It's like having one of those books when you're traveling in a foreign country that does some translation of your key, where's the bathroom, kind of things. Yeah.
And so you I want to touch on wrap async, which you mentioned a minute ago. So let's talk about that. When do you use it and what does it do?
It's usually been done for you. If you're using Meteor core libraries, you don't have to use it. It's really for interoperating with some other API call. For example, there is a DDP client library. So if you find yourself needing to do a DDP query from the server, that is the kind of thing where you'll be back into. At least I didn't find a fiber-oriented version. It was, callbacks. And so Meteor wrap async could wrap that callback taking function to allow it to, perform synchronous looking, right? So synchronous coding style that doesn't actually at runtime, block up the server.
Right, or you might be using an NPM package to access some API, and inside that NPM package, they're just using standard Node HTTP API, and there's no fiber stuff happening there. So you can wrap that with wrap async, and because of that standard method signature that you talked about earlier, it will just call the right callbacks in the right place for you, and you don't have to know about it.
Right. But emphatically not for Mongo at this point in time do you ever need to do anything like that. With respect to the Meteor wrap async too, it assumes a very specific function signature, and so it's useful in those cases. I found that the DDP client library, one of the big popular ones, I installed it as an npm.js package, but it didn't have the signature of the function in the right place to use with Meteor wrap async. So I was sad faced there.
Right. Okay. And so I guess kind of maybe the last thing we should touch on is just what can you do with the promise library, the OKGrow promise package that you wrote? Yes.
All right. So OKGrow promise it was a package that attempted to address a few things before the Meteor community actually started addressing them. So the first thing that it did, which now is provided if you go to a Meteor 1.2 upgrade, is that it gave you a promise implementation. So we know that newest browsers have promises in them, and older ones don't. So because promises can be just written, there's a polyfill for them, and so OKGrow promise provided a promise polyfill for browsers that didn't have them. Now it just delegates to the Meteor promise library. Then the other thing that I did was, for the first scenario that I saw the need for promises was for Meteor method calls. So Meteor.call the OKGrow package exposes meteor.promise, which takes the parameters of a method call, but allows you to omit the callback parameter and then chain things onto there. The name of that has recently been also aliased to call promise, and the community is talking about making a standard eventually that'll be different than that. But because I released it with meteor.promise, meteor.promise is what most people who use this library use. So that's going to be supported for a little while. Mm-hmm. And then it gained a few additional functionalities, namely the http.call was another case. There was several cases around Meteor where, on client side, you have to pass a callback. I don't have the complete list here, but definitely the HTTP method calls can be done promise style on the client as well now. It basically adds methods to that package. And also, what else? Oh, yes, Sashko Stubilo. Basically, I have to give him some credit and thanks for working with me on this package. It was when I was trying to when I was trying to return the result of the Meteor method call from a helper was my very first scenario. I looked, Sashko had a library that did it. I didn't think it did it super well. I found a bug in it. I reported the bug. He's like, yeah, that's a bug. That kind of stinks. And so, we've kind of ping-ponged back and forth. And he actually likes this current implementation of OKGrow Promise. And he suggested for subscription handles. So you do a meteor.subscribe, and we all know that it gives you a handle object back on which you can call .ready. And that's a reactive the ready state of a subscription is reactive, and you can continue to use that. But on Sashko's suggestion, OKGrow Promise adds a field to that subscription handler called ready promise. And so at the moment you subscribe, you can tack on a behavior at that point by doing meteor.subscribe, the name, the parameters, .ready promise. And I don't remember if you need to call that as a method or not, but then that returns to you the promise onto which you can start saying .then take away the spinner, .then prompt the user for something else. You can chain your additional actions. You can still use the reactive machinery to make that happen, but it allows you a more express way of tacking on behavior.
Cool.
I think that's about it. I don't want to include much more. I think that's pretty much it.
Cool. So it lets you use promises instead of callbacks on method calls, on HTTP calls from the client, and on subscribe, on the subscribe call, meteor.subscribe.
Yep.
Cool.
Yep, that's it.
Cool. Okay.
Yeah.
Well, I think that's been a good overview of all things asynchronous in Meteor and promises, and probably a good place to leave it.
We hit the big ones.
What did we miss?
No. I was just looking like that. The 5 different kinds of async that I mentioned. Callbacks, promises, on the server, fibers, and then reactivity. And reactivity is async, because at the time that you set a reactive var, any auto runs that are dependent on that, they do not get run right away. They do not get run synchronously. And this is the flush cycle that is built into Meteor reactivity. So that ensures that at the time of setting a reactive var, any auto runs that may do some more additional work, I have a guarantee, just like I have with promises, that any of those will occur later and not slow me down now. Yeah, so that's it. And I think that's only 4 types of async, but callbacks, promises, reactivity, and fibers.
Cool. Okay. Thanks, Dean. So do you have any...
Thank you.
If you have any other resources, we'll put them in the show notes, links to anything else interesting online. And how can how can people get in touch with you if they want to?
You can find me on Twitter at DeniusDev. And I work at OKGrow, and we have several packages in the OKGrow namespace and on GitHub. Find any issues, or want to submit a pull request or bounce ideas off of us. So GitHub and Twitter mainly.
Okay.
Denius on GitHub, DeniusDev on Twitter.
Okay, great. Thanks, Dean.
All right. Thank you, Paul. I promise that I'll give you those resources.
Nice. Okay, thanks. Thanks for listening. If you liked this show, you can subscribe using iTunes or your favorite podcast app. For more info, visit meteorinterviews.com. To learn more about OKGrow and the work we do, you can find us at okgrow.com.